This feels like number 4, lecture number 4 on this topic, or this section. We are still doing, and we should finish up support for chapter 2 today. Previously, we've looked at rounding. So let's re-explore some rounding real quick. Let's say we have the number 0.2468. And recall if whatever the number to the right is, if it's 0, 1, 2, 3, or 4, we round down. And if it's 5, 6, 7, 8, or 9, we round up. So that's a quick refresher. Let's say we want to round this to the hundreds place. Hundreds place. That looks funny. I don't know that I've ever written out the number. It should be spelled out like that. Hundreds place. So the hundredths place is right here. We look to the number to the right. The number to the right is a 6, so we're going to round up. So we've got 0.2, and the 4 is going to go up to a 5. 0.25. So that would be rounding to a hundredths place. Let's say we decided to change our mind and said, no, let's round to the tenths place. I'm going to show what happens if you continue from the 0.25, or if you go back to what we started with the 0.2468. In both cases, if we looked at the tenths place, the number next to it, or the tenths place is the 2. The number next to it on the 0.25, the 5 says 5, we're going to round up, and that would make this 0.3. In this case, we have a 4, and it says to round down, so this would go to 0.2. So, which is correct? You just pointed, that means 0 to me.
I mean, I would probably say that side since it's the original.
What's that side? Like
right side.
The right side.
0.2.
This is the correct one, yes. 0.2468 rounding to 0.2. 0.2 is the correct value. The problem with the 0.3 is we rounded and then re-rounded. And the first rounding changed the final output. Changed it. So the moral of the story here is don't re-round. Don't re-round. This is bad juju. Don't do this. Don't re-round. Bad juju. Always go to the original. You guys ready for another? A couple people are still riding. Patience.
What do we get?
My weekend was all right. I got some work done. I watched The Pope's Exorcist with my wife. I liked it. I normally don't like scary movies, but I don't think it was a scary movie. It was just a horror movie. And there's a difference. Scary movies scare me and they fucking make my blood pressure go up. Horror movies just have fucking horrible things in them. So they usually overlap because they usually make the horror things do scary shit, but they don't have to. I'm always hesitant though. Like, I don't like being scared or startled. I hate jump scare shit. The movie Lights Out, where like the monster only appears in the dark. Oh my, I saw that movie in the theater with my wife. And like, it didn't bother me the first couple scenes because I knew the premise of it. And then there's just one scene where the person's on the couch and then they're inside, so it's dark enough that the monster is just crawling up onto the back of the couch. And I heard this like, and I realized it was coming from my own throat, like a scared dog. And I just started laughing right in the middle of the movie. And my wife just like jumped because she was like on edge. She's normally not. She takes me to scary movies so she can look at me and laugh. Like she's like, you're the little bitch at scary movies. All right. We'll talk more about weekend when we get done with this shit. We got to get through this stuff today. So, should have given everybody time to finish up. Let's take a look at another one real quick. Let's say we have 0.429. Let's add another 9. And let's round to the thousandths place, or 3 digits. Okay, so this one's the 9. This, we look at it. We have a 9, we have a 5, 6, 7, 8, or 9. That's in the round up category. So I should take that 9, but when I take the 9 up, 9 going up is a 10. And I can't put a 10, which has 2 digits, in the slot for 1 digit. So what happens here is when you have like a 9 and it needs to be rounded up, go and look at the digit before it. And we're going to round up the 29 rather than just the 9. The 29 would round up to a 30. So that's how we deal with it. Rounding up a 9, grab the next digit to the left. Now, the homework should take uh, 0.43 or 0.430. If it asks for 3 decimal places, it will take both. The correct answer is the one with the 0. Now, it doesn't change the value. The 0 is not changing the value. That 0 doesn't change the value over 0.43 with no 0. What it does is it provides that 0 at the end confirms our accuracy. and where we rounded. So if I round it up to, if the result is a 0.430, I know I rounded, I was either below it, I had from 0.42 like 95, or I could have gone all the way up to 0.43 like 04. That tells me my range of what I rounded from. Anything in that range will round up to 0.430 or down to 0.430. If we just have the 0.43, then starting numbers could have been, well, it could have been 0.425 all the way up to 0.434. So like keeping that 0 there tells us like we're more accurate. This is a wide range. This is a bigger range than that range. So it's just a level of accuracy. Any questions? Everyone ready, or does anyone need this longer? Okay. All right. Everyone ready? You need it up, say something, otherwise I'll take the speech. Let's look at comparison signs. You all are very comfortable with the equal one. But we have less than and less than or equal to. So the first one here is less than. And the second one is less than or equal to. We can also have ones where it looks like a mouth opening to the left. This is greater than. And then greater than or equal to. So let's say we are looking at 4 versus 6. Is 4 have a lower value than 6 or a higher value than 6? It's got a lower value than 6, so lower is also less than. So we say 4 is less than 6. We can also use that one. with the equal part. 4 is less than or equal to. In fact, the difference between the two is if I have 5.99999999999, and I keep putting nines, I can either say less than, or I can say less than or equal to 6. Both of those will work. But if it's a 6 on the left, the only one I can do between those is 6 is less than or equal to 6. Now, this seems kind of silly because you would say 6 equals 6, right? The problem is usually one of these, this is usually an unknown value. And we use the symbol to set a maximum value for it. So if that was X is less than 6. That means X can go up to, but not get to 6. $5.999999999, that's okay. 5.99999 is not 6. Now, one of the things students struggle with a lot is remembering which symbol goes with which, and the best way I can recommend doing it is writing down 2 numbers that you know and reading it from left to right. Put the symbol in that works correctly. And a lot of times students will say this is 4 is greater than 6. That's what I mean by they get it wrong. They know that 4 is lower in value than 6, but they forget what this symbol is. So like if you forget what this symbol means, read it both ways out loud. Like go, is 4 less than 6 or is 4 greater than 6? And one of them sounds right. 4 is not greater than 6. Right? So hopefully that will help. The way to remember what symbol to use is we got the symbol. And I like to throw vampire teeth on that motherfucker. It's a starving vampire and it always wants the bigger meal. That's for people that like vampires. For people that like video games. That motherfucker's Pac-Man. Pac-Man kicks ass with the bigger pellets. Pac-Man goes for the bigger pellets. They both have that symbol there, though. This is a less than symbol. So I had 4 less than 6. If I put the 6 first, though, if I compare 6 and 4, If you don't like the vampire analogy, you go with alligator. Something that's got a big mouth. I don't know. It likes the bigger number. So 6 is bigger than 4, so it's going to go after the 6. And if you're going, how do I read this? Try reading them out loud in your head. Is 6 less than 4 or is 6 greater than 4? Without looking at the symbol, most of you will say less than or greater than, because you know 6 is the larger number. So let the numbers tell you what the symbol means. Eventually, you get to the point where you don't make that mistake. You're not going to write the right symbol and then say the wrong word. The reason why this matters is near the end of the semester, like the last 6 weeks, 5 weeks, we're going to be comparing a lot of numbers to 0.05. And I will drill into you, if the number is less than 0.05, you do one thing. And if the number is not less than 0.05, like it's 5 or higher, you do the completely opposite thing. And they'll put the wrong symbols because they don't have the symbol notation down their head. So it looks like they don't know the answer at all, like they got it wrong. And I think it's just the symbol notation for them. So practice up on those symbols. How do we do it when we're comparing decimals? What? We do it the same way, but a lot of times, I'll show you 2 examples where, like, let's start with the 6 and the 4. Let's say I've got 0.006 and 0.004. And then we're going to look at 0.04 and 0.008. We're going to look at both.
Yeah, please. But it was still be more than that.
So you think this is the higher one?
Right now. That's what more is in the second phase.
So rather than ruminating out loud, let's go through and see what happens. Go in order. The zeros are not meaningless. When they're in a decimal, they're not meaningless. They actually mean something. Like 0.90 or 99 or 90 is 90 cents. 0.09 is 9 cents. Granted, that's not a big difference for your wallet, 90 cents versus 9 cents. But if you had that same mistake like 100 million times, we're talking about a shitload of money that's off. So like the zero matters. So compare one decimal place at a time. Starting on the left. Keep going right until they don't match. That's when we're going to make our decision. So The first one matches, the number before the decimal matches. These two match. These two match. These two do not match. So we're gonna look between the 6 and the 4. The 6 is larger than the 4, so the 0.06 is larger than the 0.04. We do the same on the next one. Again, the starting numbers match. The first decimal place matches. The second decimal place does not match. One is a 4, one is a 0. So the one with the 4 is going to be larger. A lot of students get the top one correct, but make a mistake on the bottom one because they ignore the zeros. And they see the 8, 8 is larger than 4, so they make the alligator go for the 8. But you got to do them decimal place by decimal place. Okay? Sound good? All right, what about comparing fractions? Does anyone need this up longer? You're not even writing. Are you raising your hand for Ashley? Wow, so Ashley's got you.
Yeah, she's good.
She's got you trained. Fucking raise your hand for me, boy. I ain't raising my hand. I said, put your hand up, boy. All right, let's look at comparing fractions. How does 11 over 13 compare to 16 over 19? Think of all the fun shit we've done with fractions right now. And I want to see that panic in your eyes. I want to see it. Panic for me. And then that way I can go, fuck fractions. This shit, we're not comparing this shit by hand. Let's go to decimals. So in the calculator, we do the number on top divided by the number on the bottom. I don't know what those are. I just made those two, pick those two numbers randomly. The 16 looks like a larger number than the 11, but like 16 is 3 away from 19 and 11 is only 2 away from 13. So I don't know what we're going to get, but I'm going to find out. Helps if I turn on the calculator. I can't even see it. Motherfucker. Okay, I can see it now. I guess I can't just show it. So this one is 0.846. 15. I don't know how many spaces I'm going to need. 16 divided by 19 is 0.84210. So I go through and compare them. You're all free to confirm this on your calculator as well. I got a high degree of match there, don't I? The zeros match up, the 8s match up, the 4s match up. We get to the third decimal place, and the third decimal place we got 6 versus 2, which means the number on the left is bigger, which means we go up to the fractions, and 11 over 13 is bigger than 16 over 19. Whoa. I'll do that shit with fractions. Like fractions, if you want to do it with fractions, you got to get a common denominator, and it's just too much work. Why would you do this when we got calculators? Like, I like math, and I'm not even that sick. Sometimes if they're simple fractions, I'll do it, but like 13 and 19, those aren't simple fucking fractions. Same thing with multiplication, so if you're multiplying decimals. You could do it at a calculator, like 0.04 times 0.2. You can do in a calculator if you'd like. This is one of those I would do by hand myself. If you want to do it by hand. Find out how many total decimal places there are. There's 2 there, there's 1 there. Find total decimal places. And our answer will have that many. Then just multiply the numbers. 4 times 2 is 8. And I need 3 decimal places, so I'm gonna put it behind a couple zeros. This gives me 3 decimal places. So it always goes at the end. If you have to add zeros anywhere to get more decimal places, you add them in the front. For doing this multiplying by hand. If you go to a calculator, you'll see that you get 0.008 just fine. Or will you? How can I get you to fucking show what I want you to? This says 8, and then there's a little tiny times 10, and then there's a negative 0.03. Right? Y'all see that? Does anyone know what that's called? So, go ahead. Actually, be brave. Coward. Coward.
3/8. That's what she's saying. She's trying to say 3/8.
I'll show you. She didn't say it, so there's nothing wrong with being wrong though. Okay, nothing wrong with being wrong. So when I did it in a calculator, I got 8, and then there was a point like that, and then mine had a little tiny times 10, and then there was a negative 0.03. This is called scientific notation. We'll cover this more a little bit later, like when we get to chapter 5 stuff. But just for your information, what the scientific notation means is whatever that exponent is, it means move the decimal point that many times. If it says a negative, like it does here, you go left. If there's no symbol or it shows a positive, you go right. Or no symbol. So we had 8 times 10 and there's a point right there, -0.03. I'm gonna move that decimal point left 3 times. 1, 2, 3. I'll put the point there, and if I have to add zeros to do it, I will. So 8 times 10 with the -0.03 turns into 0.008. Okay, other things that might speed up doing this in a calculator. Like 9/16, I would just divide. This would go into a calculator. This is calculator work. And I'm gonna get 0.5625. However, if I had something like 51/1000, I would not use a calculator. The reason why is it's so easy to do this. This is not calculator work. It will slow you down to get the calculator out. You take the 51, put the point at the end of it, and then count the number of zeros. If it's a 1 followed by zeros on the bottom, this always works. This always works. Count those zeros. And then move the decimal left that many times. If there's no decimal, you put the decimal at the end of the number, like 51. The fraction doesn't have a decimal in it, so I just put it at the end to start with. Now, if I count those zeros, I've got 3 zeros. So I'm going to move that decimal left 3 times. 1, 2, 3. I'll put the point there. I got to fill in a 0. So 51/1000 equals 0.051. This actually works with multiplying by a number like that too. Slightly different. Have you ever looked at those later on, actually? The photos. I found when I took photos during lecture, I never looked at them later. Like I just never did.
Well, it's because you're right.
What do you do if the teacher's going too fast?
Well, she just stays behind it. How are you showing that? She's probably done the last page, that she took a picture of.
So just ask me to slow down. Am I going too fast for anyone else? Oh, never mind. You actually suffer.
Okay.
If you're not willing to ask, I'm not slowing down. You gotta say something. We only got a few minutes left. Multiplying by . 1 followed by zeros. We still count them. But now we move right. The decimal right. What?
I was saying in my head, so divisions and that multiply is right.
Yeah. And if it helps you, look at the number, like. Well, in fact, let me just put it right here. Let's put it in something you'll recognize. If we had 3.59 and I multiply it by 10,000. And if you're unsure if you should go to the left or the right, picture that as money. You've got $3.59 and you're multiplying it by 10,000. What should happen to your money? It should go way up, right? So like if you write them both down and if you went to the left, you would quickly see that that's not going to work. How many times do I got to move that decimal? I've got 1, 2, 3, 4, which means I need to go 1, 2, 3, 4. I need to add 2 zeros after that 9. I'll plop them in, the decimal goes there, and then I'll go back and put commas in afterwards. Like picture it as money. Same thing goes with the division. Picture like having $100. If you're dividing by 100, like you're giving your money out to 100 people, each person is getting less.
Do you have to add zeros after that decimal, or does it matter like when you put it in?
You don't need to add zeros after it. Unless you're talking about money and they show decimal. This goes the other way. Going from decimal to fraction. Zero point 0042. Here we count the decimal places. And use that many zeros on bottom. So I've got 4 decimal places here. I'm going to put 42 on top and a 1 followed by 4 zeros on bottom. Those zeros match the decimal places up above. Now, I don't know that the computer is going to take this. Holy crap, I'm still not going to. Oh yeah, but I don't want to page. It's this. we still need to simplify. Did multiplying fractions before, right? And then like shit like that, where we canceled shit out. So that's what you kind of want to do here. Write out 42 is what it is. 42 is 7 times 6, which is 7 times 2 times 3. You can write out, this is 10 times 10 times 10 times 10 on bottom. Or you can just go, well, no, let's stick with that. And then one of these 10s, I'm going to break down to a 2 and a 5. I can cancel the 2 out. And on top, I have 7 times 3. On bottom, I have 5 times 10 times 10 times 10. This will be 21 over 5,000. Now, your calculator might do this for you. Let me see if mine does. Ooh, look at this. I put in 0.0042. And when I add equals, it writes it in scientific notation. It has the 4.2 times 10 to the negative 3. I have this button here. I don't know if you can see it very well. Let's see if there we get it. A with a B over C. If I hit it, look what happens. It shows 21 with that weird symbol and the 5,000. That 21 weird symbol 5,000 is meant to look like this.
What did you push again?
The thing that has an ABC. Now, if you don't know where this button is on your calculator, you can show me your calculator. I might be able to find it for you.
The phone calculators have that? No, huh?
There are fucking 15 million different phone calculators
Can you
made
download
by, there's apps made by everyone.
Oh, okay.
I can't tell you whether the app you use does until I see it. But there's that, or you can simplify it by hand. One last little topic for this section, then we'll be done with chapter 2 support. And we got to talk about percents. So decimals to percents. Zero 0.0345. Only 2 steps. There's 2 steps in this. Okay. Move the decimal right twice. I'll say 2 times in case you don't know what twice means. B, add the percent symbol. Here, I will move it left or right 2 times. It'll go right there. So 0.0345 turns into 3.45, and then I add the percent. Percent to decimal. We're gonna do the same steps, but backwards. Well, maybe not same steps. I'm gonna say reverse the steps. So we'll drop the percent symbol. And now we will move it left twice. If I've got 0.15023. Percent. Hey, if I move it left twice. It actually gets smaller. I'm gonna have 0.0015023 without the decimal. So it's an even smaller number. For those of you that are walking in for Math 21, this is the Math 321. It's the support shit. So like some of this, you're like, this is a fucking handy reminder. I forgot some of this stuff. You are more than welcome, if you're free, to show up from 4 to 5. Or alternatively, in your Canvas section, I scan these lecture notes and I upload the YouTube video. So like I'm recording this, I'm gonna put it on YouTube and I'll put a link there. So like you're like on a section, you're like, I don't remember how to do some of this math. You can go skim the lecture notes there that I scan. I'll show you in a second what I'm talking about. In fact, they'll be good. I'll wait till everybody gets here. I'm gonna hit stop record there because that's it for that.